You probably see it every day, but how often do you really see it? Let's talk about milk. It seems like the most basic food in your fridge, right? But its journey to your glass is this whole hidden world of amazing biology, clever chemistry, and some seriously cool technology.
So, what is actually going on inside that glass? It's not just some simple white liquid. Nope, it's a perfectly balanced, microscopic universe. And we're going to dive right in. Okay, so get this. A huge chunk of milk, about 87% of it, is just water. I know, that sounds kind of boring, but trust me, that watery part is what makes the other 13% so unbelievably cool. That's where all the real magic is happening.
And in that other 13%, you've got this awesome mix of stuff. There's lactose, which is just milk sugar. It gives it that little bit of sweetness. Then there's fat, which creates that rich, satisfying feeling. And finally, the real heavy hitters, proteins and minerals. Think of them as the tiny architects of milk. All right, let's put on our microscopic goggles and zoom way, way in. We're going to look at the invisible stuff that makes milk, well, milk. And we have to start with its most important protein.
Everybody meet casein. This stuff is the undisputed superstar of milk protein. I mean, it makes up a massive 80% of all the protein in there. Seriously, without casein, you can just say goodbye to cheese and forget about yogurt. It's absolutely fundamental to the dairy world. But casein is way too cool to just float around aimlessly. No, it gets organized. It builds itself into these incredible little spheres called micelles. You can think of them like tiny little delivery trucks, packed with crucial minerals like calcium, keeping them perfectly suspended throughout the milk.
So how do they stay afloat so perfectly? Well, it's a brilliant piece of natural engineering. The parts of the protein that hate water, the hydrophobic bits, they all hide in the middle of the sphere. And the parts that love water, the hydrophilic ones, they form this kind of hairy outer layer that just loves to hang out with all the water molecules. It's this clever design that keeps everything from clumping up.
And this incredible structure, this is the secret we exploit to make cheese. See, if we want those little micelles to clump together, we've basically got two paths. Path 1, add acid. This messes with the charge on that hairy outer layer, and they all start sticking together, which gives you soft curds for things like cottage cheese. Path 2, use an enzyme called renin. This stuff literally goes in and snips off those protective hairs. The micelles get all unstable, and bam, they clump together into the firm, calcium-packed curds you need for cheeses like cheddar.
So, we know what's in milk, but how do we get it from the farm to your fridge safely? Raw milk is basically a party for bacteria. So, to make it safe and consistent, it has to go through some really important processing.
And step number 1 is a big one, pasteurization. It's just a heat treatment to kill any nasty bacteria and make the milk last longer. And the way we do it has gotten way faster over the years. We went from a slow 30-minute low-heat bath to the super-fast high-heat flash that's done in 15 seconds, all the way to this ultra-high-temp blast for just 2 seconds. That's what gives you that shelf-stable milk you can keep in your pantry for months.
All right, quick question for you. If you've ever had milk fresh from a farm, you know that thick layer of cream always rises to the top? So why doesn't that happen with the milk you buy at the store? Well, the answer is our next process.
It's called homogenization, and it's pretty intense. They take the milk and force it through these teeny tiny openings at insanely high pressure. Now, this doesn't get rid of the fat. Instead, it just completely shatters the big fat globules into millions of microscopic droplets, so small they literally can't float up to the surface anymore. And stopping the cream from separating isn't the only thing it does, not by a long shot. Homogenization is the reason your milk has that bright white color. It's why it has a richer, smoother mouthfeel, and why it's exactly the same from the first drop to the last. It fundamentally changes the experience.
Okay, so now we have the safe, perfectly uniform liquid. This is where the fun really begins, because now we can turn it into this whole universe of different foods. This is where milk really gets to show off.
One of the biggest transformations is fermentation. This is how we get all those cultured products. We basically add specific types of good bacteria to the milk. These little guys are like microscopic chefs. They get to work eating the lactose, and as they digest it, they produce lactic acid, and it's that acid that thickens the milk and gives it that classic tangy flavor. And what's so cool is that by just tweaking the recipe, using different bacteria, changing the temperature, we can create this huge variety of stuff. From the thickness of sour cream, to the tang of buttermilk,
to the bubbly, probiotic-packed goodness of kefir, it all starts with that same basic idea. It's incredible.
And that brings us to what might just be the ultimate milk transformation: cheese. What is cheese really? It's just a genius way to take all the best parts of milk, that casein protein and all that rich fat, and concentrate them down into this solid, delicious package that can last for months or even years.
All right, that was a lot of science, but let's bring it back to reality. How does any of this help you when you're standing in the dairy aisle trying to figure out what to buy? Let's break it down.
So the biggest choice you usually make is about fat. Whole milk, 2%, 1%, skim. The only real difference between them is how much fat is in there, and that, of course, is what changes the number of calories. The other good stuff, like the protein and carbs, that stays pretty much the same across the board.
And you can see that calorie difference pretty clearly here. It's a really simple trade-off, right? More fat gives you that richer taste, but also more calories. Less fat means fewer calories, but the milk is going to be a bit thinner.
Now, for a lot of people, the biggest issue with milk isn't the fat, it's the sugar, lactose. If you're lactose intolerant, it just means your body doesn't make enough of an enzyme called lactase, and without it, the lactose doesn't get digested properly and ends up fermenting in your gut. And, well, that's just not a good time.
But here's the good news. Being lactose intolerant doesn't always mean a life without dairy. Remember fermentation? Those good bacteria eat up most of the lactose, so yogurt and kefir are often totally fine. With hard, aged cheeses, most of the lactose is drained away. And, of course, you can now buy milk that has the lactase enzyme already added to it. So you've got options.
I love this quote because it just sums everything up perfectly. That simple thing we all know, that mild, sweet flavor and that creamy texture, it's not simple at all. It's the result of this incredibly complex symphony of fats, proteins, sugars, and minerals, all working together in perfect harmony. So the next time you open your fridge and pull out that carton, I hope you see something a little different. Will you see just plain old milk? Or will you see this amazing masterpiece of biology and technology? It's something to think about over your next bowl of cereal.